Hello everyone, in this video we're going to take a look at a question called Alice Through the Looking Glass. It's from 2011's Canadian Computing Competition. So this one is, okay, not gonna spoil it. So let's read the problem and then you guys can pause the video to think it yourself, try to come up with a solution, and get back to the video to watch the explanation. Alice is looking at a crystal through a microscope. Blah 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 blah. A lot of like random words to describe this question, but generally, so it's basically the microscope has the ability to zoom, and at each zoom level, the image is presented as a grid cell, like a chessboard, and the crystal is always blue, and the blue cells will be here, like it doesn't change, it will always be this area. Okay, so what if you zoom in even more? So the blue area will still stay blue area because you have more precision and more accuracy, like you can observe the scene better. So if you notice some like small edges on the crystals like top, so it will, the image will be like this. So you know the crystal itself is still blue, but because the zoom level is higher, so you can see more details, which give you some more blueness on top of the original thing. So as you zoom in, all those like small cells will always have something on the top, like that. So there are 4 cells on the top. So the problem is asking you, given a zoom level and the what is it? The coordinate of the cell, you gotta determine whether that cell is blue or white. So if it's blue, you just output crystal because crystal is blue according to this problem or the coloring of the graph. If it's white, it will be white. I mean, you just output empty. So let's try to come up with some solution. Whether it's dumb or smart, just try to brainstorm. So the first thing we should do, we should think of is simply this thing. But it will give us a complexity of 5 to the power of 26 in worst case, which is clearly bigger than 5 times 10 to the power of 8. So we can do a little bit of factoring over there. I mean, not factoring, it's something like that. So it's like 2 to the power of 8 times 5 to the power of 8. So it's like 5 to the power of 9 times 2 to the power of 8. So 2 to the power of 8 is something around, okay, let me calculate. 256 times 5 to the power of 9, and you know this number is clearly bigger than that, like way bigger. So it means it can get some partial but not full square. So the second solution, or the smart solution we can come up is to check recursively. So we can make an observation of, we can divide the whole graph or the whole image into 3 parts or 3 types of area. So if the area is here, like the bottom 4 cells, like big cells, you know immediately that is a blue. Sorry, this one it's a little bit out, but you get it. So it's just this area, big chunk. So at any zoom level, if it's on the bottom 4 cells actually, then you know it is a crystal. That is simple as that. If your cell is somewhere here, then you know it is potentially to be a blue cell. It can be empty, it can be blue. So for example here, the bottom 4 of this big cell is blue. I mean the blue, yes, the rest is white, but we don't do that at this point. We and the rest of the plot, it will always all be yellow. And now if we are given a coordinate or a position, and we're just gonna check if they fell in yellow or blue. If otherwise, if it's in a potential blue cells like these areas, then we're just gonna recursively zoom into that particular area and check it again. And that's our strategy to this problem. So let's try to implement this. So it's basically recursively checking the cells. So if we cannot identify it's a blue or white, we just zoom into the area it belongs. Okay. So first thing we gotta do is include, did I cap it? Bits stdc++ dot h. Main. So we gotta handle test cases, so we just use a while loop, taking inputs. Let's see the format of our input. The first thing gives us the first two number. The first number gives us a magnification level, and the second and third number gives us a coordinate. So let's call it mag and x and y. So we will recursively check it with like a function called check level. It has some passing parameters. We just pass in the current level, zooming level, and our coordinate. Okay. So we can just pretend we have our check function ready. So let's pass in our mag, x, and y. So if it is a blue cell, we check if it's a blue cell. We just see out crystal, and end our line. Otherwise, we output. We output what? We output empty. Yes, empty. Ty. And that's our main function. So now we're just gonna implement our checker function. So now let's try to come up with like how we're gonna divide the whole grid into subgrids, like the area grids, what we use to determine which area it falls to. So the area's length, so length of area equals to power of 5 to the power of level minus 1, because it is 1/5 of the length of the entire grid. Then we create two new variables, x1 and y1. So x1 will be the specific area inside like the intermediate area. So this one is like if it is like, so if a point is fall into an area, but we still gotta know like where specifically it falls in the area. So x1 equals to x mod length of area, and y1 equals to y mod length of area. So we know where exactly it is. because we have the area code and their specific coordinate within the area. So if if our if their area is in this column and that column, we know like for sure they are not gonna work. So let's use an if statement. So if x equals to, sorry, before doing that, we gotta put them in the areas. So x equals to x divided by 5, actually length of area. So it automatically runs it to the area it belongs to, and y divide equals to length of area. So if x equals to 1 or 4, we know exactly it is not gonna work. I think I gotta use braces here. Actually, no. If now we gotta check if they're in these 4 cells or not. So these 4 cells are definitely yes. So let's make them. So if x equals to 1 and y equals to 0. Wait, actually it's 0 to 4 because our grid start from 0. So if x equals to 1 and y equals to 0, so this boy I'm referring, then it work. So just gonna do some copy paste to make this simpler. Wait, what? We just changed the xy, so x2, y2, x3, y3, oh, sorry, x, y0, x3, y0, x2, y0, x 2, y1. So we're just gonna return yes. Return true. Otherwise, it is potentially possible, so we return check and their specific area code like we got here. So let's pass them in. So the level got it decreased by 1. So level -1 and x1, y1. So now this code should work. Let's test it out by trying the sample. Okay. So wait, how do I do this? How do I run the code? Okay, F5. Wait, give me a second, man. I'm not too familiar with this editor. Oops. Yeah, I think I found the reason. We forgot to sing and now let's do it. So 4, 1, 1, 1. Wait, what happened? Okay. It seems like we experienced a stack overflow. Oh, also we forgot to check whether it is a potential area of blue. We just treat everything potential area, so which is not right. So we return false at the end, and we check if the area is potential is one of the potential areas. So we just do some if-else statements, and that should work. So what do we have? 1 1 1 1 and 2 1. Wait 2 2 1 1 2 2 3 1. Okay, let's just put them in 1 1 2 1, no, 2 2, and 3 1, and y equals to 1. Also, we are zooming in recursively only if the level is above 1. So if level is bigger than 1 and below condition, we just recursive check it. So let's draw our code. So 4 1 1 1 empty. Okay, it seems like our first test case is right. So 1 1 0. Can you guys see it? Oh, let me just make it bigger. Crystal, okay. And 1 2 1 is crystal 285. It's also crystal. So it seems like all the sample passes. Let's try to put our code in the grader. Okay, so it seems like we have an error which is floating point exception. Let's try to solve it. It's somewhere here. Okay, I'm just casting auto int just in case if there's any errors. Resubmit. Still, okay. This is very interesting. Okay. Just trying to make everything integer, just to avoid error. Okay, let's try to run this again. Still, bruh. This is not fun. Wait, actually, this is not wrong. Okay, so I found a bug. So it was I missed a semicolon. I mean, braces. So it caused some logic errors. So before that, it was like, so if this case work, or this case alone work, that case alone work, it will just proceed, which is gonna cause us error because it's because the level cannot always be above 1 if to recurse. So that's wrong. So let's try to submit again. And as you can see, all the test case passes. So thank you for watching. Bye.